Hi folks, in this video I share a visit to the Lake Superior shore to look at a particular Arctic disjunct plant, specifically Purple Saxifrage. Now, I was not certain if I should create this video. Why, you ask? No, it's not because the location is secret. In fact, the location is posted on iNaturalist, so it is public. I was reluctant because the hike into the locality is tricky. Now you might be thinking, tricky? I'm a little fuzzy about the meaning of the word tricky. Well, access to the area is partly along an active railroad track, and that can be dangerous. In fact, I'm not even advocating that you try to get to this location. There are frequent trains that pass along this rail. Safe escape options are limited. One side of the rail bed is a cliff, and the other side of the rail bed is a steep drop into Lake Superior. So, if you're wondering how we manage the hike, I'm not joking when I tell you that we assess the route every 50 meters or so to determine our safe exit strategy in the event that a train did pass while we were on the rail bed. No joke. And yes, one freight train did pass while we were hiking in, but fortunately, we were safe in the bush at the time. Nevertheless, that was exciting. So, with that context, let's get on to our quest for the Purple Saxifrage. Why the quest for the Purple Saxifrage? Well, there are two reasons to seek out the Purple Saxifrage. Reason number one, the plan for spring 2022 was to seek out many of the Arctic disjunct plants along the Lake Superior coast. Recall that an Arctic disjunct plant is growing hundreds of kilometers south of the expected range in the Arctic. So seeing any Arctic plant along the Lake Superior coast so far south from its expected range is always exciting. Reason number two, for the Arctic disjunct plants I saw, I wanted to determine if the geological substrate has an influence on the siting of the plant. In the case of the Purple Saxifrage, was the substrate calcareous? In other words, was it rich in calcium? Given that Purple Saxifrage is a calcicolous plant, in other words, a plant that prefers or seeks out or tolerates calcium-rich substrates. To simplify, in this area are the two occurrences of calcicolous Purple Saxifrage growing on a calcium-rich substrate. To help us understand the rock substrate of this area, let's review the bedrock geology in this part of the Lake Superior coast. Geologists create maps to show the geology of an area. This is a simplified geology map showing the rocks that together make up the Coldwell Complex. Each color represents a different rock type. The Coldwell Complex is an unusual group of rocks that are interpreted to have once been a magma chamber located deep below the Earth's surface. Data suggests that the Coldwell Complex as a magma chamber was born about little over 1 billion years ago, and that's pretty old. In the spirit of keeping this discussion simple, the rock of interest is colored dark brown on the bedrock geology map. Geologists call this dark brown colored map unit an alkaline gabbro. This type of gabbro rock contains quite a bit of calcium. That's available to help create a calcareous habitat if the gabbro reacts with near-surface water in such a way to release the calcium from the rock. One clue that I look for to indicate the release of calcium from the gabbro rock is the presence of white-colored coating on the rock surface. Again, lots of calcium-rich lime scale on the surface of this rock, part of the Coldwell Complex. That white-colored material is a precipitate of the calcium-rich mineral called calcite. That precipitate formed when calcium-rich waters reacted with the Earth's atmosphere close to or at the Earth's surface. And sure enough, there are several areas along this coastal area where the rock surface is coated with that white material, likely calcite. So we appear to have satisfied one condition required to create a calcareous or calcium-rich habitat that would support a calcicolous plant, in other words, a plant that thrives in a calcium-rich environment. Sadly, geological life is not always so simple. Not all white coatings consist of the mineral calcite. I also saw white-colored material that appears to be a type of glue that was injected by engineers into the rock to help hold the rock in place. You see, there is danger of rockfalls in this area, and a lot of work has gone into holding the rock cliff in place and warning trains should a rockfall occur. so we have to look carefully to distinguish between the white-colored calcite coating on the rock surface and the white-colored rock glue.
In fact, there are areas where you can see the lime dripping off the rock. Or perhaps that's actually a cement that was used to hold the rock together by those who were here, for example. Sort of a rockcrete.
In contrast to rock cement, there are places where the rock face is wet and coated with a calcite precipitate. By now, I suspect you're wondering, where's the star performer, the Purple Saxifrage? Well, I never saw any. The two observations reported on iNaturalist were made by superb field botanists, so there's no issue with the quality of their observations. Perhaps the Purple Saxifrage has died out in this area. Alternatively, perhaps I just did not look in the right places. Or, if I was in the right place, my eye just missed the plant. Disappointed? You bet. But that's life. And I saw lots of other features and plants, so that was good. So as a consolation, let me summarize some of the other spring flowering plants that I did see growing in this calcareous, rocky habitat beside Lake Superior. Here's another example of a calcicolous plant that is growing on the gabbro cliff face. The calcicolous plant is Steller's rock-break fern. The fern grows along a crack in the gabbro rock where calcium-rich groundwater seeps out and calcite precipitates. The faint white rock coating is the calcite precipitate. That precipitate creates a calcareous or calcium-rich habitat that supports the calcicolous Steller's rock-break fern. Cool, eh? Two other flowering plant species that I saw growing in calcareous microhabitats on the gabbro rock were early saxifrage and rock whitlow-mustard, or Draba arabescens. Although not considered to be a calcicolous plant species, early saxifrage certainly tolerates calcium-rich substrates based on its ability to grow on a wide range of rock substrates, including limestone and dolomite. Rock whitlow-grass is another plant species that is not explicitly stated to be a calcicolous plant. However, along the Lake Superior shores, it is found on exposed dolomite, limestone, and basalt substrates in Wisconsin, Michigan, and basalt substrates in Ontario. At this Mink Bay locality, both early saxifrage and rock whitlow-grass grow on the Coldwell Complex gabbro rock that is locally covered by calcite precipitate. Primula mystacinica, informally known as bird's eye primrose and Mystacini primrose, is a calcicolous Arctic disjunct plant species that frequents calcium-rich substrates. When I visited this Mink Bay area, it was in full bloom and graced the dark-colored gabbro rock with its mauve-colored inflorescence.
Lots of primrose here. Bird's eye primrose, presumably. You can see the rock above it is just covered with a lime scale, suggesting that the microenvironment is quite calcareous. Lots of calcium.
Primula mystacinica is not a rare Arctic disjunct plant, but its spatial association with the calcium precipitate on the gabbro rock highlights this plant species' calcicolous nature. Three other plant species that I saw on the gabbro rock of the Coldwell Complex were shrubby sancfoy and Artemisia, possibly Artemisia campestris coda, informally known as beach wormwood, and Athalos liverwort, possibly common liverwort, Marchantia polymorpha. Now, liverwort is always exciting for me to see, as liverworts were one of the earliest terrestrial, non-vascular plants to colonize the surface of the Earth about 470 million years ago. Liverworts, therefore, are an ancient and special plant lineage, given their terrestrial evolution at the beginning of land plant history. So let me summarize what we saw along this segment of the Lake Superior coast. First, we saw plants, at least one of which is an Arctic disjunct plant species that tolerate the Arctic lake conditions created by the large body of cold Lake Superior water. Second, we saw evidence that the gabbro rock of the Coldwell Complex has and is reacting with groundwater to release the element calcium from the rock-forming minerals. That calcium precipitates on the rock surface, where it creates a calcareous or calcium-rich habitat. That calcium-rich habitat supports calcium-tolerant plants and calcium-loving calcicolous plant species. So it is true my quest to find the purple saxifrage failed, but the cold, calcium-rich conditions needed to support the calcicolous purple saxifrage do exist along this part of the Lake Superior coast. Now, I remind you that I am not a botanical expert, and what I shared in this video are just observations made through the eyes of a geologist along one local coastal area of Lake Superior. No doubt there are other explanations and other observations to be made, but those are for another day and another story. Thanks very much for watching. Bye for now.